Good morning. We're looking at homework 4.7, and several of you asked about number 8, so let's take a look at number 8. So as I look at number 8, the absolute value is already isolated, and so I'm going to write the piecewise for the absolute value. My first equation will be 5 minus 2x, and that will be if 5 minus 2x is greater than or equal to 0. And so in the process of solving that inequality, I'll end up getting the domain for that piece is x is less than or equal to 5 over 2. And if you think about it, that makes sense, because if I were to graph this absolute value, I would factor out the negative 2. I would be left with x minus 5 over 2. So graphing that would be a reflection over the y, a horizontal compression by 1/2, and then right 5 over 2. So what is your right-hand piece? What would be here is being reflected due to the negative, and then a compression, and then moved right. So, I mean, this would be your original right-hand piece. It's not your left-hand piece. So that makes sense with our domain. My other will be the opposite of 5 minus 2x, and that will be if x is greater than or equal to 5/2. From here, let's write our two inequalities. 5 minus 2x is greater than 3. But I know any answer that comes out there must be less than or equal to 5 over 2. So as I saw that, I'm going to divide by a negative. I get x is less than 1. So actually, all values that are less than 1 are also less than or equal to 5/2. So this interval, this piece, is producing the solutions negative infinity to 1. For my other piece, oops, this shouldn't have had an equal to sign on it. X is greater than 5 over 2. I'll take the opposite of 5 minus 2x and set it greater than 3. I'll divide by a negative. Subtract. Let's see, divide by another negative, so my sign will change once again, so I get x is greater than 4. Well, all values greater than 4 are also greater than 5/2, so I'll have 4 to infinity. So as I think about these two intervals that are solutions, the only way that I can write them as one interval is a union. And there we go. We're going to look at number 11 next. And we're trying to solve for x. I'm going to multiply both sides of my equation by bx to eliminate my denominator. So when I distribute, I'll get x plus 2b squared will equal 2bx. I'm solving for x, so I'm going to put all the x's on the same side and move over the negative 2b squared. We can factor an x out and then divide. An equivalent answer would be, you could factor the negative there out of the denominator and get a positive 2b minus 1. And then you have a negative in the numerator. You could actually cancel those and say you get positive 2b squared over 2b minus 1. That would be acceptable as well. Look at number 9. I'm going to subtract 14. As I subtract 14, 6 minus 14, I'm going to get negative 8. You actually could have stopped here and told me, you know, absolute value is not going to be less than a negative number, so it will be no solution if you were doing it one way. You could also come over and sketch the graph. So I think about this absolute value graph. It's a horizontal compression and move left. So, I mean, it's going to be something like this, equals a negative 8. So we could see, where is the absolute value graph below negative 8? Well, it's not. So that would also be all real. But let's say you did the algebra. So 6x plus 25, and that will be if x is greater than or equal to negative 25 over 6. And the opposite of 6x plus 25 if x is less than negative 25 over 6. So let's write our two inequalities here. So my first inequality, 6x plus 25 is less than negative 8, will be 6x is less than negative 33. X is less than negative 33 over 6. And so let's see, I can cancel a 3 out of those, negative 11 halves. So I've got, oops, you guys couldn't see that. I've got x is less than negative 11 halves. But as I look at my answer here, oops, I know 11 halves is negative 5 1/2. Okay, so let's go back up here. What's negative 25 over 6? Well, that's negative 4 1/2. So I'm looking for x values that are less than negative 5 1/2, but they also need to be greater than negative 4 1/2. Are there any values that are less than negative 5 1/2 and greater than negative 4 1/2? No. So that piece actually does not produce any solutions. As I look at the other piece, I'll take the opposite of 6x plus 25 and set it less than negative 8. I'm going to divide by a negative. Okay, let's subtract. So x is greater than negative 17 over 6. Well, that's what, negative 2 5/6? So do I have any numbers that are greater than negative 2 5/6 but are also less than negative 4 1/2? No, I don't. So this has no solution. By the way, the notation that you see on your paper where you see brackets empty, that's called empty set. That's called empty set. So that is actually representing the solution there. So either, no solution or empty set. It's cut off, but here's the answer for number 5.